Well, so we have a question right here. Excuse me. So they say evaluate the following. Limit x approach to 3 and then x cubed plus 2 x squared minus 5, just like how we see. But the same question also is one of the sort of letter here is one of the book. So write that one right there. Let's get started. Let's see 2.1. Let's get started. Let's go. So now we go. This is the question. Let me start with the first one. So what I'm going to do with the first one, solution for the first one. Okay, so the first one is not tricky. Most of the time, do not substitute the limit if you have not simplified. So this one, there's no way we can simplify, like maybe cancel something. All we can do, we can just expand it. So for 2.1, so I'm going to say I have my limit. Okay, my limit, and then I'll say, okay, let's expand x cubed times x squared. This is going to give us x power 5 because the base are the same, add the power x power 5, and then x squared, x cubed times minus 5x going to be minus 5x power 4. Now the second number with the face on 2 times x squared equal to plus 2x squared. Now let's go for the last one. Plus and minus, and then 2 times is going to be 10x. So what we can do right now, we can just substitute the limit in. Okay, let's plug the limit in. Okay, so now we still have our limit x approach to 3. So the moment you substitute the limit, don't write the limit anymore. So this is equal to, like when you say limit means put like now in the position of x, put this number. So we're going to say that's going to be 3 bracket equal 5, and then minus, we have here 5, and then the position of x, we're going to put 3 here, and this going to be power 4, and then minus plus 2, and this going to be 3 power 2, and then minus 10, and then after that we substitute here the position of x by 3. So if you plug in the calculator, that's going to give you, plug in the calculator quick. If you plug in the calculator, that's going to give you negative 174. So there's going to be negative 174. So for that case, if I have a limit, okay, limit x approach equal to 3 of exactly what I had, x power 5 minus 5. Or you can just take this original one, see this one, all this equal to negative 174. Now let's go to the question number 2. So the question number 1 is done. We go to question number 2. So question number 2, I'm going to explain to you a little for absolute. How does the absolute works, okay? So I'll take another paper here, quick. Now, let's do the absolute now. So somebody, excuse me, sorry. Okay, so limit, so we say x approach to negative 4 from the negative, okay? And then we have here bracket x plus 4, and then here we have x plus 4. But the top number here, we have absolute. So for the people who don't know absolute, if anything comes inside the absolute, always positive. For example, if I have this x, and then if you put negative 2 here inside, it's going to come as a positive. Even if you put positive inside, when it comes out, it's going to come as a negative, okay? So what is the absolute meaning? Now let's go to the question. Okay, so now this case here, I'm going to draw a little graph so I can explain to you what that means from the question. Okay, now let's say you have a Cartesian plane here. This is a Cartesian plane. Okay, if this Cartesian plane means this is y and this is x. Okay, that's a y, that's a x. So what that mean? Look, if you have absolute, means anything is not on the negative. That's what I say here. Anything come in the absolute is going to come out as a positive. Like nothing. Okay, let's say negative 3. If you put absolute, it's going to come as a positive 3. It's not going to be negative anymore when it comes out here. Even if you say negative 10, if it comes out here, it's going to be positive 10. But the positive is going to come out as a positive because it's already positive. For that case, whenever you draw the graph of absolute, you're always going to be on positive y. For example, if somebody say this is x, right? This is x, and then plus 4 absolute. What does that mean? Means this graph is going to be on top. But now, what is the called x-intercept? We know whenever x-intercept y equal to 0 means, excuse me, sorry. So now, if I had to equate the, okay, let's assume absolute, okay, ignore the absolute. If you take along this, means it's going to be x plus 4 equal to negative 4. Because this is going to go over, excuse me, x plus 4 equal to 0. So x equal to negative 4. So our x-intercept equal to negative 4. Okay. So for that case now, I'm gonna say, oh, so if I had to draw this, means x at the negative 4, and this graph absolute always like this. That's absolute how it works, and we know it's never gonna come to the negative part, because you know anything comes in absolute is gonna be always what? Positive. So for that case now, I'm gonna say my x-intercept is negative 4. Now let's come to the business here. So now you see, x approach to negative 4 from the negative. Okay, x approach negative 4 from the negative. Excuse me. So I'm gonna say, okay, now let's go. So we approach negative 4 because in any limit we have two cases. So it's approach from negative 4 from the negative line. Let's go now. So we come from the negative, we come to negative 4. So what happened? Means we're gonna reach on a negative side, because look, if I come here from negative 4 from the negative, look, I'm gonna approach negative 4, but from the negative side. Oh, so for that case now, I'm gonna say from the whole this game here, we're gonna say limit s approach to negative 4. Negative 4, excuse me, just a second. Negative 4, but our limit here is gonna be what? It's gonna be negative x plus 4. I'm gonna remove absolutes, I'm gonna put negative, because if I come to negative 4 from the negative, look, I'm gonna attack the graph. But what is our graph? Our graph is this. You know what I'm saying? That's our graph, but it's gonna be on the negative because you come from the negative. That's why I wrote this negative. I'll remove absolute right here, just say negative, and then at the bottom I'm gonna write my x plus 4, just like how I given x plus 4. So what happened now? Excuse me, this negative from negative. So what happened? This and this is gonna cancel because similar thing. Okay, so don't cancel when you have absolute still. So for that case, this is gonna give me limit x approach to negative 4. Okay, x approach to negative 4, and then what happened? And since this and this cancels, and this is the same thing, 1 1 is going to be negative 1, because this and this cancel, so it's 1 1. Negative 1 times 1 over 1 equal to negative 1. But look, if you substitute the limit here, limit is not going to have any effect there because there is no x, so it's just going to be negative 1, you know, because a limit of a constant is just a constant. So now we're going to do the same thing, now walking to negative 4, but from the positive. Look, which side I'm going to touch on the graph? I will touch on the graph, but what is the graph? The graph is this absolute. You remember? You know what I'm saying? Try to remember that this graph I draw is for the one of the numerator. You know what I'm saying? Numerator. Okay? So for that case, if I look at the numerator, okay? So means if I limit now, so on the right hand side, so this is the limit of the right hand side. Now we go limit x approach to negative 4, but from the positive. Because you must do left hand side and then right hand side. You know what I'm saying? So from the positive, now we're gonna say, okay, now let's go. So here, if we reach the graph from the positive, what happened? Means it's gonna be on the positive side. So I'll say this is gonna be positive, and then x plus 4. Unlike the other one, it was negative because it's coming from the negative of the graph. So then you have to say, at the denominator, we still have x plus 4. So at the denominator, it's just x plus 4. So what happened? This and this cancel. So we still have our limit x approach equal to negative 4, but here it's going to be positive 1. But a limit of a constant is just a constant. Because look, this is x minus 4. There's no x here, so it's not going to have any effect. That's why a limit of a constant just a constant. So if you look careful, the limit on the left hand side is not the same with the limit of the limit of the left hand side is not the same with the limit of the right hand side. So according to the rule of limit, for the limit to exist, you know what I'm saying, for the limit to exist, the limit of left hand side, it must be equal to the limit of the right hand side. So limit of left hand side is not equal to the limit of right hand side. So for that case, this limit does not exist. So for that case now, limit, because on the left hand side we got negative 1, which is not equal to positive 1. So for that case, the limit given, which is x approach equal to negative 4, and then here x plus 1 at the denominator, okay, is what? Is x plus 4. We know absolute doesn't exist. Does not exist. Doesn't exist. Does not exist. You know what I'm saying? So, I hope you learned from my methodology and how I do the things. Thanks a lot for your time. And that's the solution for the second question. Thanks. Bye. I'm Hamish. It's a lot of people who are new here in this channel, in this program, okay? So if you first time right here in these intellectual things, intellectual property, come right here, see here, subscribe and leave a comments. I'm gonna be more than happy to help you. Another things, again, I want to say thanks so much for all the people who donated to me, who donated. It means a lot. It's a lot of money you guys are saying to me. It means a lot because I got a lot of projects that we're doing, feeding the people, homeless people, motivates, taking all these kids from the street and bring their dream to reality. So thanks a lot for all your donation. It means a lot.
Ayapuma matoda